In this segment, we're going to talk about one of the most important aspects of using the DSTS sensor system, namely the connection between the sensor and the fiber. This is probably one of the most important things to handle properly when using the instrument. The typical optical fiber will have two ends, of course. The tips of the fiber are very small. Only 9 microns, that's 9 thousandths of a millimeter in diameter. So any form of contamination or dirt will disrupt the signal and harm the performance of the instrument. It is very important to keep all fiber ends and connections clean, both on the fiber and on the instrument itself. Let's explain why. First and most obvious, any form of dirt in the connection will block the light. If light is not going through the fiber, obviously we will not be able to sense anything. Secondly, even if light can get past any dirt on the tip of the fiber, the dirt itself can also generate reflections. Those reflections go back into the instrument, and that will disrupt the behavior of the instrument itself. Thirdly, and probably most importantly, any dirt within a fiber connection will actually get crushed between two fiber ends, and in the process will damage the tip of the fiber itself. You might not notice anything wrong the first time around, but after 1 or 2 connections, your signal will go bad, you will not be able to recover it, and you will probably have to send the instrument back for costly maintenance and repairs. So all these things must be avoided. One thing to keep in mind is that it only takes one dirty connector to damage dozens of connections. Anytime you make one connector that is dirty to another connector, you damage that second connector. You contaminate it. And it, in turn, can damage something else. So one bad connection can introduce multiple sources of damage in your system. That is why it's extremely important to keep these connections as clean as possible. So the first thing you should try to do is prevent dirt from being introduced on the connections to begin with. An ounce of prevention, as they say, is worth a pound of cure, and this is doubly so when it comes to working with fibers and connections. First of all, try to minimize the number of times you have to connect and disconnect fibers from the instrument. If you're using the device in a standard setup, leave the fibers connected as much as possible. The second rule to keep in mind is to cover your fibers and connection ends when you're not using them. The instrument comes with covers protecting the receptacles when you're not in use. So when you're storing the unit or not using it, keep these ends covered with the mating receptacles. The same thing holds true with fibers. When you're not using an optical fiber, please protect it with the cap. Make sure that the cap just slides over the housing and is not pushed all the way to the bottom. Because if you push it all the way to the bottom, then the inside of the cover may touch the tip of the fiber, and you don't want to do that either. The same thing holds true for any mating fiber-to-fiber receptacles that you may be using in your setup. Always cover the ends with caps. Now, on many of the instruments, we provide E2000 connectors. These connections have the advantage that they have a little lid that covers the tip of the fiber automatically when you're not using it. So this saves an important step. However, I should emphasize that any cap or cover, while a good idea for protecting the fiber, is not necessarily protecting it 100% of the time. So you cannot assume that simply because there's a cover that automatically goes over the end of the fiber, that this means the tip of the fiber is automatically clean. So it's most important that you always inspect the ends of fibers before you make any connection and clean them if necessary. In this next segment, we will show you how to inspect the ends of the fiber and what to do to clean them, both on the ends of an exposed fiber and in the instrument itself. Now, in order to ensure that the ends of a fiber are clean, or the end of a receptacle is clean, you need some sort of microscope to inspect it. There are many types of fiber microscopes on the market today. There are handheld ones which you hold up to your eye to inspect the fiber from the other end. There are portable video display instruments which have probes that can either be hooked up to a fiber or to a receptacle to inspect the fiber ends. These, in fact, are devices that we recommend using with our instrument, and our distributor or dealer will be able to provide you a model suitable for your setup. And there are even lab-type devices with large screen displays that are suitable for a workspace environment where things are set up permanently. For the sake of the video, we'll be concentrating mainly on using this display so that you can see it easily. We'll inspect the ends of this fiber. Now, this is a 1 meter long fiber and is of the type we normally supply with the instrument. We normally hook this up between the DSTS sensor and your sensing fiber. Why do we add a fiber in between? Simple. This device can be hooked up once to the Brillouin sensor, to the DSTS sensor, and once attached, you may hook this up multiple times to your sensing fiber. The advantage is if this ever gets damaged, you can simply remove it and replace it with a new fiber. It makes a lot more sense to replace a $10 patch cord than to have to repair an instrument that costs tens of thousands of dollars. If you find that these fibers are too long for your application, we also provide these sleeve-through connectors, which have the male connector on one end to hook up to the sensor and a female receptacle on the other end to hook up to your sensing fiber. So these provide a compact way to measure, to connect up your sensing fiber to the Brillouin sensor while minimizing the risk of damage to your instrument. So let's show how to inspect the end of a fiber. So simply remove the cap, plug into the instrument, and focus. This is an example of a damaged connector. You can see contamination running along the side here, and if you look carefully with things properly in focus, you can see contamination across the fiber core. For comparison, a good connection should look like this. The surface of the fiber should look clean all the way across. This is the actual core, cladding and core of the fiber, the part that carries the light. It should be clean, smooth, and uniform, with no signs of dust, scratches, or contamination. So our job is to take a fiber that was dirty and contaminated and make it look like this, clean. So we'll show that in the next segment. So let's discuss how to clean the end of the connector. There are several different ways of doing it, depending on just how much effort you want to spend in order to make a device clean. Simplest method is simply by using some optical tissue. Now this has to be optical tissue, not just ordinary tissue. It has to be clean, great tissue. As well as some isopropyl alcohol or acetone. Again, these need to be very clean grade chemicals. Ordinary acetone and alcohol that you could buy in, say, a drugstore is not sufficient. It has to be rated maximum cleanliness in order to ensure your connectors are clean. The technique is to simply place a couple of drops onto the tissue to make a damp spot. Take the end of your connector and rub across the wet spot in a figure 8 pattern. At the end, wipe from the wet onto the dry so that you dry off the connection. This should remove most of the dirt on the connector. Again, don't assume that just because you clean the connector that it is now perfectly clean. Inspect it again with the microscope before using it. Another useful tool for cleaning these connectors is what's known as a connector cleaning cartridge or reel cleaner. This is one here. It has a window which covers a piece of protective fabric. And the fabric has a microweave structure to wipe away dust and dirt. By adjusting the knob, you expose a clean piece of the fabric, and to clean the connector, again, you just wipe across the surface. One advantage with this type of cleaner is that you do not need to keep chemicals such as alcohol or acetone around. It is a dry cleaning process, which is quite convenient. And this type of device can be used hundreds of times before you need to change the reel inside. Now, if you want to clean an E2000 connector, you need to move the door covering the connector away. And to do that, you require a connector tool. This device slides over the connector and pushes the lid back, exposing the connector tip. You may now clean it using a cartridge cleaner like you would any other type of connector. Now what about cleaning inside a receptacle which has a fiber mounted inside? For example, cleaning the female receptacle inside these compact feed-through patch cords. To do that requires one of these connector cleaning pins. At the tip of these pins is the same sort of microweave fabric inside these cleaning cartridges. To use the pin, simply insert it inside and rotate the gray dial. This will actually wipe a fresh section of fabric across the connection tin, cleaning the receptacle in the same manner that this type of cartridge cleaner cleans the end faces of the fiber. We also have one for the E2000 connector, which will go inside an E2000 receptacle and reach all the way inside. And once inside, simply plunging inside will automatically clean the receptacle inside. It is important that after cleaning a connector, you inspect it one more time to ensure that you have properly cleaned the connector. So let's also check the receptacles inside the instrument as well, because you cannot be certain that those are clean 100% of the time. So to inspect the inside of these receptacles, we will use this portable display, as it has a probe for going inside the receptacles themselves. So we'll pull off one of the covers, plug it in, and off to the side, away from the fiber, there is actually quite a large piece of dirt. Now, that piece of dirt is not near the fiber right now, but that doesn't mean that that may not move later. And so a connection or two from now, that could get in front of our optical path. Meanwhile, since it is on the connector itself, it will get crushed between the two ends of the connector. And as a result, it will spread across connections and cause damage elsewhere. So it's important that we clean that away. So to clean the inside of the receptacle, we will use one of these connector cleaners. Remove the tip, insert inside the device, and press down to activate the cleaning mechanism. A couple of swipes should do it. Insert the probe, adjust the focus, and we see that that speck of dirt is gone, and we have a clean fiber in. So now the instrument is ready to use. So, in summary, always protect the ends of your fibers with protective caps and protect the receptacles of your instruments whenever it's not in use. Always inspect and clean all connection ends before connecting fibers to the instrument. Use sacrificial patch cords between the DSTS sensor and your fiber to minimize the likelihood of damage caused by your fibers being mated and unmated to the instrument. With proper care and handling, the Brillouin sensor system will work for you for years to come. Thank you.